How to make ragdolls. So you want to have fun with ragdolls. The first thing you need is a well-made mesh that is suitable for ragdoll simulation. Here I'm using the animation library model from Quaternius. I call it Al. Place the model in a scene and attach the ragdoll component to it. Next we need to create bone collider shapes for Al's skeleton. See the video about hitboxes for some more details. With the bone shapes in place, the result looks like this. The bones are just a loose set of rigid bodies. They are completely disconnected. So next we have to set up joints between the bones. Just select all bones for which you created shapes and set their joint type to swing twist. Make sure to reset the stiffness and the swing and twist limit values to their default values, as they often start out with 0 values. Now you should be able to see all the joints. Save the skeleton and try again. That already looks a lot better, but there is some undesirable behavior at the start. To debug ragdoll joints, first set the gravity factor on the ragdoll component to 0, then simulate again. Now that looks freaky. The reason for this behavior is that every joint defines an allowed range of motion. If a bone is outside this range, it will be pushed towards the allowed range. Apparently some of our joints are not correctly set up. The pink cones show in which direction the bones may swing. Looking closely at the skeleton, we can see that the thigh joints are pointing into the wrong direction. Select the bones and click the Local Rotation property to enable a rotation gizmo. Then rotate both bones downwards. The feet have similar problems. Save the skeleton and let's try this out. The result is better, but there are more problems in the shoulders. The rose wedges show how far a bone may twist. The orange spikes indicate that the upper arms are outside the allowed range. Let's first disable the upper arm joints entirely to verify that they are the problem. Apparently those two joints are the main culprit, so let's fix them. Set the joint type to swing twist again and enable the rotation gizmo. Rotate the joint until the twist indicator is within the allowed range. While we are at it, we also want to give this shoulder joint much more range of motion, both for swinging and twisting. The shoulder joints are typically the most difficult to set up, and tweaking things until they work right can be challenging. Go back and forth between the scene and the skeleton asset to see the simulated result. If necessary, enable only the one problematic joint and tweak it until you found parameters with which the simulation doesn't produce artifacts. Now we can finally enable gravity and see what happens. As a next step, we want to make the motion ranges of the joints a bit more anatomically correct. For example, the knees should not be able to bend that way. Here we want to allow a large swing angle along one axis, but only little swing along the other. We then need to rotate the joint such that the shins can bend backwards but not forwards. The thighs should be able to swing much farther and more outward than inward. The elbows are similar to the knees, however it is often hard to know what the right bend direction is. Finally, we have to run the poor guy through an extensive set of tests. Once we are happy with the results, it's showtime.